Welcome back to another brand new series. You may have already guessed from the title of the video. We'll be discussing the topic of factoring. Now, this series will have at least more than one video because of the number of problems we have to go through. So without further delay, let's get started. Now, what are we really trying to do when we factor a mathematical expression is to break it down to a point where you can have a positive value and a negative value. And that's precisely what I'm going to do with the first problem. The first problem is very simple because it essentially captures the essence of what factoring really is. Now, to go ahead and solve this problem, you need to figure out a way to extract a positive and a negative value. We know from our prior knowledge that a squared minus b squared equals 0. Always assume the expression to be equal to 0. It just makes your life easy. Now, if we expand this, then we know a minus b times a plus b equals 0. We can then estimate a equals b or a equals negative b. Now, in a real world situation where you have a variable and a number, this will be even more evident, but you can see that I'm able to extract a positive value and a negative value. So how could we convert this x squared minus 16 into a format where we could exactly do what we just did? So if we could use our background knowledge of squares, then we know 16 is nothing but 4 squared, right? So x squared minus 4 squared mimics a squared minus b squared. Then we can write x minus 4 times x plus 4 equals 0. Hence, x is equal to plus 4 or x equals minus 4. Now, if you notice, for most of these problems and most of the problems, the rest of the series on SAT mathematics, I try not to include the multiple choices unless the multiple choices are going to really help you solve the problem. These are all questions with multiple choices, but I chose not to include them because I want you to really understand what it is that you're doing. And in the process, you should be able to solve the problem without any hints or cues or clues or whatnot. So I try to not give you the choices. If I feel the choices definitely going to enhance your learning, then you would see the choices provided on the screen. But for the most part, it would be more like approaching a question that is descriptive in nature. So this is how you solve the problem. Now, the question could literally stop right here where you've decoded the expression x squared minus 16 into x squared, x minus 4 into x plus 4. The question could literally stop right here, or they might ask you figure out the positive integer, then you circle the answer as 4. If the question asks you circle x is a negative integer, then you circle negative 4. All right, because there's no multiple choice, there's no particular answer we're going for. We try to work out the problem in its entirety. All right, moving on. This is a problem that's quite contrasting to the problem that we just discussed, because you can't just simply approach the second problem in the same fashion as you did the first problem. Now, how do we go about doing this? You're asked to determine this equation, right? First, let's write x squared minus 2xy plus y squared. What is this really equal to? It is same as writing x minus y squared. So essentially, if you could find x minus y, then you can find the square of it and you're done with the problem. So if you notice, x cubed minus y cubed is nothing but x minus y terms x squared plus xy plus y squared. If you don't believe me, go ahead and solve it. Well, we would precisely do this in the next series of videos on FOIL, which is a distributive property. We'll get to that when we get to that. Okay, so if you multiply these two terms using the FOIL method, then you would get x cubed minus y cubed. Okay, if you even still doubt me, go ahead and solve it at your leisure time. You'll find out that I was right. So now we know that X cubed minus Y cubed is 30. So it's 30 equals X minus Y times X squared plus XY plus Y squared. So this whole term is nothing but 6. So X minus Y times 6 equals 30. Therefore, X minus Y equals 5. And we have to figure out X minus Y squared. So X minus Y squared equals 25. This problem by no means is so that's essentially your answer. So you can also write this as X squared minus 2XY plus Y squared equals 25. So they're both the same. Now, this, like I said, this problem by no means like a 10 out of 10 difficulty, but it definitely captures the essence of factoring, because the factoring is seen in X cubed minus Y cubed, because just like how we did the A squared minus B squared equals 0, we should also be able to decode X cubed minus Y cubed, which is nothing but X minus Y times X squared plus XY plus Y squared. Now, this is not something you would encounter every time you take a SAT math test, but it's something you need to know if you're going to approach the concept of factoring. All right. So if you have no questions, let's move on to the next problem. This is much easier. Okay, so I would try to contrast maybe one easier one with slightly more involved process. So if X minus Y equals 4, X squared minus Y equals 34, what is X? All right, let's go through this. So we know that X minus Y equals 4. And so either convert X in terms of Y or Y in terms of X. Okay, you have to do it one way or the other. Otherwise, this problem could get out of your hand pretty quickly. So I'm just going to do X equals 4 plus Y, right? So that means I'm going to substitute this value of X equals 4 plus Y in the expression X squared minus Y equals 34. So that means it's 4 plus Y squared minus 5 equals 34. Now let me pause here for a second, because it's very important in math. Whenever you solve a math problem, particularly algebra, it's very, very critical that you use brackets. Now you see, I didn't just write 4 plus Y squared. I automatically put the 4 plus Y into a bracket, because then that gets you used to the process of solving an algebraic expression. This is nothing but A plus B O squared. So it's 16 plus 8Y plus Y squared minus Y equals 34, right? So that's nothing but Y squared plus 7Y plus 16 equals 34, right? That's nothing but Y squared plus 7Y. If you put the negative 34 on both sides, it'll be negative 18 equals 0, okay? 80. Now, this is where it kind of gets into quadratic equation, but I want you to teach it right here. So how could we solve this? We want negative 18Y squared, right? If you multiply these two terms, you get a negative 18Y squared. But we want a plus 7Y, right? So that means if you multiply plus 9Y times negative 2Y, we get negative 18Y squared. Why do I do this? Because only when I add plus 9Y minus 2Y, I get plus 7Y. It's very important that you see that. We want negative 18Y squared. I'd rather take my time here and explain this once very clearly, so that as you get to quadratic equations, you would see this concept being very, very useful. So if you want negative 18Y squared, you can think of ways you can get 7 between two terms that could also give you negative 18Y squared, but also gives you 7. The best of the world is 9 and 2. So we put the plus to the 9 because we want the 7 to be plus and the 18 to be negative. So it's plus 9Y times negative 2Y gives you negative 18Y squared. But if we add them, then we get 7Y. So this is precisely what we substitute in place of 7Y. So we could say Y squared plus 9Y minus 2Y minus 18 equals 0, because I've just substituted 7Y with this term. Now, this is one part. This is the second part. That will give you the two factors. So in here, if I take the y out of the equation, it's y plus 9. And here, if I take the -2 out, then if you take negative out, if there's a negative term, it becomes positive. So it's y plus 9 equals 0. So essentially, we combine these two terms. So it's y minus 2 and y plus 9 equals 0. Now that is same as y being equal to, I'm going to write it here, y being equal to plus 2 or y being equal to -9. Because the question does not specify. Okay, now this is why we have to get x. We're not done yet. So x equals 4 plus y, right? So you can say 4 plus 2 or 4 minus 9. So that's 6 or -3. These are the values for x. Now the question does not state whether x is positive or negative. So technically you could have had a multiple choice with either 6 or -3, unless the question says both. So that's how you solve this sort of problem. The key here is here. This is going to come back over and over again. Everywhere you go, it involves factoring. It may come across even FOIL. It may come across quadratic equations. So this is very important. We'll do more problems like this when we get to quadratic equations. But for now, I want you to understand this for what it is. All right, this is a much, much easier problem. So if x squared plus 2x plus 81 equals 0, a is 9. So let's go ahead and write this equation first. Plus 81 equals 0. So a is 9. So that means x squared plus 18x plus 81 equals 0. Now again, we're back to the same concept I discussed. We want 81x squared, right? We want plus 81x squared. It's a positive sign. But we also want 18. How could we also get 81 and 18 using two numbers? That would be 9x times 9x, right? That'll give you 81x squared. But then because the 18x here is positive, it doesn't even matter. Just add 9x plus 9x equals 18x, right? What we multiply should also be added or subtracted to get the desired value. So now we substitute 18x with these two. So it's 8x squared plus 9x plus 9x plus 81 equals 0. So again, we split this two parts. So x times x plus 9. Plus if we take the 9 out of the bracket, then it will be the same. So essentially it's x plus 9 times x plus 9 equals 0. X is in both cases -9. The question again does not specify whether x is positive or negative integer, so x can only be one here, and that is a negative integer of -9. So we'll do more problems along these lines, and I feel like we've approached the time limit for this video. I'll see you in the next video with more problems on factoring. So stay tuned.